force and pressure. Introduction to concept of pressure. Look at the boy who is enjoying pleasant sunset on the beach. Why did he stop? He is looking at his footprints. Now that boy is lying on the beach. When he gets up, there is no sharp mark of his whole body as he found while walking. Why did this happen? Pressure. Pressure is the answer to boy's question. Let's learn more about pressure. When boy is standing or laying on the surface of sand, his body applies force that exerts pressure. In first case, the force is applied through the foot, which applies large amount of pressure. Due to this, he is able to make sharp footprints on the sand. In the second case, the whole body is in contact with the surface. So, the force is applied through the whole body, which applies small amount of pressure. Similarly, it is easier to fix the nail in the wooden block from pointed side, while it is almost impossible to fix it from the head side. So, we can define pressure as the force acting on a unit area of a surface. Pressure is equal to force upon area on which it acts. The area is in the denominator in the given expression. So, the smaller the area, larger the pressure on a surface for the same force. Let's see some more examples related to this. Balloons can be easily burst through a nail as compared to a finger. The smaller area of nail's tip exerts much more pressure than a broader fingertip. In case of a pair of scissors have sharp edges. The small area of edges helps in exerting a large pressure even for smaller forces. It helps in cutting the cloth easily. Pressure exerted by liquids and gases. Look at the water tank filled with water. Let's make one hole in the tank. Water starts flowing out of the tank. Now we make another hole at the middle of the tank. At last, third hole at the bottom. Take a close look at the amount of water flowing from the three holes. The first hole has less pressure, that's why flow is slow. In case of second hole, the pressure is more, so the flow is little fast. In third case of third hole, as it is present at the bottom, it experiences the highest pressure, so water comes out with high pressure. So we can conclude that pressure exerted by water at the bottom of the container depends on the height of its column. Now try to stop the flow at the bottom of the tank with your thumb. You will feel the pressure of water on your thumb. As you remove your thumb, water flow will start again. So we can conclude that a liquid exerts pressure on the walls of the container. What happens when the three holes are at same level? Here is a tank with three holes which are at same level. The flow of water is same from the three holes. So we can conclude that liquids exert equal pressure at the same depth. Do gases also exert pressure? Let us learn about it. Look, a cute young little girl is trying to blow a balloon. The size of the balloon increases when air is pushed inside it. It happens because air inside the balloon exerts pressure on the inner surface of the balloon. Further, the whole balloon gets stretched and acquires a spherical shape, which shows that pressure is exerted by air equally in all directions. If you push too much air inside the balloon, it generally bursts. This is because blowing too much air exerts a lot of pressure on the balloon surface. The balloon cannot withstand so much pressure and thus it bursts. So we can say that gases too exert pressure on the walls of their container. Atmospheric pressure. Astronauts wear special suits and carry oxygen cylinders in space. Do you know why? A rubber sucker sticks on a surface when pressed. Why? We will get answers to above questions when we study the air around us. The Earth's atmosphere is a mixture of gases called air. It occupies the space around Earth's surface up to a few kilometers. The pressure exerted by this air is known as atmospheric pressure. This atmospheric pressure is always present on all of us. However, we can withstand this pressure because air is present inside our body too, which exerts an almost equal pressure against the atmospheric pressure acting on our body. Astronauts wear special suits as there is no atmospheric pressure in space. As a result, if they do not wear a space suit, they will burst due to internal pressure. Space suits exert pressure on the body to balance the body's internal pressure. Why we need to breathe faster while climbing a mountain? When we move up above the Earth's surface, the air pressure reduces. It happens because the number of air molecules reduces in the upper part of the atmosphere. Due to this reason, we need to breathe faster while climbing a mountain. Summary. Let us summarize what we have learned. Force per unit area is called pressure. Smaller the area, larger is the pressure. Liquids exert pressure on all surfaces of a container. Pressure exerted at the bottom of a container increases with the height of liquid column in the container. Liquids exert equal pressure at the same depth. Gases exert pressure on the walls of their container. The pressure exerted by air around us on Earth's surface is known as atmospheric pressure.